Okay, so picture this.
You're settled into a high-speed train. Europe's whizzing by outside.
Maybe on your way to like a life-changing meeting or a long-awaited
It
vacation.
all seems so effortless
Right. But have you ever like stopped to think about the sheer complexity?
of keeping that steel giant safely on track.
Especially when you're crossing borders with like different systems and everything.
Well, that's exactly what we're going to unpack today.
We're doing a deep dive into the intricate world of railway safety,
And interoperability.
guided by this fascinating technical document I've got here.
21 Signaling Safety Interoperability.pdf.
And you've picked a good one to be curious about.
It's not just about making the trains move, right?
It's about orchestrating their every movement.
With a precision that, honestly, most people wouldn't even imagine. Like, I know there are signals and stuff.
But the sheer scale of it all is just like,
So where do we even begin with something this complex?
well, before we even get to the fancy tech,
You have to appreciate the raw physics at play here.
imagine this. You're barreling along at, say,
160 kilometers per hour.
even slamming on the brakes.
It'll take you about 1,300 to 1,400 meters to come to a complete stop.
Whoa, that's like,
That's over a kilometer.
I guess trains don't exactly have the tightest turning radius either.
Exactly.
They'll bump that speed up to, let's say,
200 kilometers per hour.
and you're looking at a stopping distance of 2,500 to 3,000 meters,
At high speeds, we're talking almost 7 Eiffel Towers.
laid end to end just to come to a halt.
Okay, now it's starting to click.
Why safety is such a huge deal in the rail world?
No sudden stops or last-minute detours for these guys.
Precisely.
And that's why, for well over a century,
Railways have been developing,
increasingly sophisticated systems to prevent these situations from even arising.
So how did we go from those old-timey images of
Like guys with flags waving down trains.
to the systems we have today?
It's been quite the evolution.
Early railways relied on those rudimentary methods, you see.
Flags, lantern,
Or even just shouting between stations
which, as you can imagine,
is about as reliable as a message in a bottle.
as train speeds and traffic increased, though,
The need for
more sophisticated solutions became obvious.
and that's where semaphore signaling came in.
A system of visual signals using those,
Arm-like structures you still sometimes see beside the tracks.
oh, right.
They almost look like something out of a steampunk novel now.
But I guess they were pretty high-tech back in the day.
Absolutely.
They were a huge leap forward in signaling safety,
Yeah,
a stepping stone to the standardized systems we rely on today.
And speaking of which, you've probably noticed those colored lights.
Red, green, yellow.
Pretty universal now, aren't they?
Yeah.
It's like the language of go, caution, and stop is like universal.
So whether you're on the road or the rails,
Exactly.
that familiarity of colors was intentional.
Making the signals intuitive for both railway workers.
And the public, of course.
Railway signaling is far more intricate,
We have home signals, exit signals, block signals.
each playing a specific role in maintaining order on the tracks.
Okay, so we've got the visual cues down.
But how do these signals actually know when a train is coming?
Or if a section of track is clear,
It's not like there's someone constantly watching every meter of the line.
that's where things get truly ingenious.
It all boils down to what we call track circuits.
Think of it like this.
Each section of the track has its own invisible on-off switch.
And the amazing part is,
The rails themselves are part of the circuit.
wait, the rails themselves.
That's wild.
How does that even work?
It's surprisingly simple.
Yet incredibly effective.
You see, when a section of track is clear,
An electrical current flows through the rails.
keeping the signal at the beginning of that section green for go,
But here's the kicker.
when a train enters that section,
Its wheels and axles connect the rails, completing the circuit.
completing the
So
circuit,
that triggers the signal to change.
telling any approaching trains to, like, slow their roll.
You got it.
It's basic physics, really.
Being incredibly reliable
This elegant system, combined with those visual signals we talked about.
forms the backbone of modern railway signaling.
Okay, that makes me feel a lot safer.
Knowing there's this, like, constant invisible communication.
Happening beneath those steel wheels.
But what happens if, like, a signal light malfunctions or something?
Is there like a backup?
That's the beauty of it.
Even if a signal light gets, say, stuck.
The track circuit itself acts as a safety net,
If the circuit's closed.
indicating a train's presence,
The system errs on the side of caution.
preventing another train from entering that section.
It's all about layers of redundancy, really.
Minimizing the risk of human error or,
Technical glitches.
redundancy is a good thing.
When it comes to something as important as this,
But we've been talking a lot about, like,
keeping trains apart.
how do they make sure no part of a train gets,
Left behind.
like in those movies where a coupling breaks?
And it's all dramatic.
That's a great question.
It brings us to another critical safety feature.
Train integrity detectors.
You might have seen
Older trains with a caboose at the end?
that separate car at the back.
Yeah.
I always thought those were just for
A conductor to look cool in?
well,
That served a very practical purpose.
older train integrity detector.
What we used to call tail detectors.
Used a simple but effective system.
They'd attach a magnet to the back of the last car.
If a sensor, usually at a station or key point,
Didn't get tripped by that magnet.
it meant the train wasn't whole.
And that triggered an alarm.
It's amazing how such a simple concept can have such a big impact.
On safety. But what about modern trains?
They don't usually have cabooses anymore.
That's right.
These days, it's all about sophisticated sensors.
And onboard computers.
These systems can detect things like,
Pressure changes in the brake lines between cars?
which would indicate a brake.
Same concept, just a 21st century upgrade.
So no more relying solely on a lonely magnet at the back of the train.
But all this tech
All these signals and detectors.
makes you wonder.
What happens if there's a power cut?
Or a single component fails.
That's where the brilliance of
Fail-safe design.
goes in.
One of the essential components ensuring this,
This humble relay.
you can think of them as the
The nervous system of railway signaling.
transmitting signals and making sure everything defaults to a safe state.
Even if there's a
hiccup in the system.
okay, so relays,
They're like the silent guardians of the railway.
making sure that even if something goes wrong,
Chaos doesn't ensue.
precisely,
They might not be as flashy as a high-speed locomotive
but they are fundamental to keeping those trains running safely.
and on schedule,
So we've got these invisible track circuits,
acting like guardians,
these train integrity detectors,
keeping things together.
signals telling everyone what's up.
And relays making sure everything fails gracefully.
It's like a perfectly choreographed dance.
Only with, like, tons of steel and electricity.
It is,
It's a beautifully orchestrated system.
and a lot of it comes down to managing one
crucial factor.
speed,
Right, because, as we've established, stopping a train isn't exactly like...
pumping the brakes on a bicycle,
So how do they make sure those trains are running at, like...
a safe clip.
Are there, like, speedometers embedded in the tracks or something?
Not quite speedometers in the tracks,
But you're on the right track.
so to speak.
Think of it this way.
Speed control has gone through,
Its own evolution.
from basic
Mechanical contraption.
to the sophisticated electronic systems used today.
Okay, so let's start with the old school stuff.
How did they used to keep those iron horses from?
Going too fast.
Ever heard of the term dead man's handle?
Yeah, it sounds kind of creepy.
But intriguing at the same time.
It does have a certain ominous ring to it,
Essentially, it was a safety feature.
requiring the driver to
Constantly apply pressure.
a lever or pedal.
If for any reason that pressure was released,
Say, if the driver became incapacitated.
the train would automatically apply the brakes.
So like a built-in,
Dead man's switch.
it's a pretty clever concept.
But also a bit unnerving to think about.
It was.
But as you can guess,
It had its limitations.
it wasn't exactly precise in controlling speed.
And it couldn't account for variables like, say,
Track conditions.
or upcoming signals.
That's where intermittent and continuous speed control came into play.
Okay, those sound intriguing.
What's the difference between the two?
Intermittent speed control
As the name implies.
worked at specific points along the track.
Like speed traps for trains, you could say?
One example is the
Mercadel. Sister.
used in France.
It was basically this,
Rattle blade assembly.
it's in the middle of the track.
Hold on, a crocodile on the tracks.
That sounds even more intense than a dead man's handle.
It does sound a bit out there.
But it served a vital purpose.
The train had a
Metal brush.
that would make contact with this crocodile.
If the train was going too fast,
It would trigger a warning.
and if the driver didn't slow down,
It could even,
engage the brakes.
so like a very firm nudge
Maybe more like a jolt.
to get the driver's attention.
Exactly.
It was a way to enforce speed limits at crucial spots
Approaching stations.
or navigating curves.
But the real revolution came with continuous speed control.
This is where things get really interesting.
Okay, I'm all ears. Tell me everything.
Imagine the track itself.
whispering instructions to the train.
keeping it in check at all times.
Continuous speed control relies on constant communication.
Between the train and the tracks.
It's like giving the railway its own, well,
Dedicated mobile network, you could say.
wait, so no more.
Crocodiles lurking on the tracks.
Well, some systems still use trackside equipment.
But it's a lot more advanced.
Imagine electronic beacons
Called balises.
scattered along the tracks
These beacons transmit data to the train.
as it passes over them.
So the train is constantly receiving information about, like,
The track ahead,
kind of like having a co-pilot.
feeding it intel.
That's a great way to put it.
And this constant stream of data isn't just about speed control.
It allows for things like
In-cab signaling.
in-cab signaling.
Does that mean what I think it means?
The driver doesn't have to rely solely on...
Those trackside signals anymore.
Exactly.
With continuous speed control.
all that vital information about the track ahead.
Speed limits, signal aspects,
Even,
upcoming curves or inclines.
is transmitted directly to the driver's cabin.
So it's like the train is giving the driver,
Like a heads-up display.
right there in the cockpit.
That must be a game changer.
Especially when you're talking about those high-speed lines
It's a huge leap forward.
in terms of
Safety and efficiency.
it lightens the driver's cognitive load
Improves reaction times.
and generally makes for a, well,
a smoother, safer journey for everyone on board.
we've come a long way from those.
Dead man's handles to trains that practically whisper to each other.
It's incredible how much technology goes into something we often take for granted.
But all this talk about, like,
Sophisticated signaling systems.
makes me think about Europe,
They've got all those different countries.
each with their own history of,
Railway development.
you've hit on a crucial point.
Europe's railway network is, well,
Fascinating case study in
the challenges and triumphs of interoperability.
and I'm guessing that's no easy feat.
It's not like they can just magically make.
All those different systems work together overnight, right?
It's a massive undertaking.
Imagine
Railways were developed on a
national basis.
each country
Sometimes even different companies within the same country.
had their own standards for everything. Track gauge, electrification.
And of course, signaling systems.
So trying to get a train from, say,
Paris to Rome back in the day.
was probably more like an obstacle course than a relaxing journey.
You're not wrong.
Imagine having to change trains at every border.
Because the tracks were different widths.
Or the electrical systems were incompatible.
It was a logistical nightmare.
Inefficient, time-consuming.
And not exactly cost-effective.
No wonder interoperability became such a big deal.
For the European Union.
Precisely.
To create a truly integrated and efficient...
European transport network.
They needed a way to, well...
get all those different systems on the same page, so to speak.
And that brings us to, arguably...
the star of European railway interoperability. ERTMS.
ERTMS, that rings a bell.
Refresh my memory. What does that stand for again?
It stands for European Rail Traffic Management System.
It's basically like creating a...
Universal language for trains across Europe.
using a combination of,
Cutting-edge technologies and standardized protocols.
So the idea is that eventually...
No matter where you are in Europe,
the trains will be able to,
talk to each other seamlessly.
you got it.
ETMS has two main components.
ETCS, the European Train Control System,
And GSMR,
which uses a specialized version of...
USM mobile technology.
specifically for railway communication.
So ETCS is like the
brains of the operation.
and GSMR is like the communication network.
That allows all the different parts of the system to,
Talk to each other.
a perfect analogy.
And while it might sound,
incredibly complex,
Yeah.
the system is designed with different levels of implementation.
to allow for
A gradual transition from those older...
sometimes incompatible systems.
It's not like they're,
ripping up every railway line in Europe and starting from scratch.
not at all.
They're taking a more
Strategic approach, you could say.
gradually phasing in ERTMS across the network,
There are three main levels:
each with increasing levels of,
sophistication and reliance on advanced technologies.
So what can you tell me about these different levels?
Let's start with the basics.
Level 1.
Level 1 is all about establishing...
Basic compatibility with existing systems.
It often still uses those,
Trackside signals we talked about earlier.
but with the added bonus of,
In-cab displays for the driver.
it's about bridging the gap between old and new
Okay, so it's like dipping their toes into the waters.
of interoperability.
What about level 2?
Level 2 takes things up a
It
notch.
relies more heavily on that,
Continuous communication we discussed.
using balises
Those electronic beacons.
and radio transmission.
To keep the trains in sync with the infrastructure.
So less reliance on, like,
Fixed signals.
and more on real-time data exchange between the train and the tracks.
Precisely.
And that brings us to the, well,
The real game changer.
level 3.
Okay, I'm ready for this.
Level 3.
This is where things get really futuristic, right?
This is where we enter the realm of, well,
What some might call smart trains.
level 3 envisions a system where
Trains can essentially report their position and integrity
to the control center in real time.
without needing to rely as much on...
Those track circuits.
Wait, hold on.
So the trains are essentially like
Communicating their every move.
constantly updating the control center on their whereabouts and status.
They're like giving the
A
trains.
sense of self-awareness.
It's a pretty radical concept.
It's still under development in many ways.
But it has the potential to,
Revolutionize railway capacity and efficiency.
particularly on busy lines.
It sounds like something straight out of a sci-fi movie.
But I love it.
Trains that are practically thinking for themselves.
Constantly communicating and adapting to their environment.
It's an exciting time to be following.
The world of railway technology, that's for sure.
But even with all this talk of,
High-tech signaling systems, futuristic trains.
and a Europe on track for seamless connectivity,
There's one aspect of railway safety that we
can't overlook.
okay, what are we missing?
We've talked about how to keep trains apart.
How to control their speed.
But what about those points where the railway intersects with
Well, the rest of the world?
those places where trains and vehicles
Pedestrians, cyclists,
all need to,
share the right of way.
You're talking about level crossings, aren't you?
Yeah, those can be a bit,
Nerve-wracking.
even with all the flashing lights and barriers.
They can indeed.
And despite all the technological advancements we've been discussing,
Level crossings remain a
critical point of vulnerability in the railway system.
they are, unfortunately.
Still a relatively common sight for accidents.
Really?
You'd think, with all the safeguards in place.
Those accidents would be a thing of the past,
You'd hope so, wouldn't you?
but there are a lot of factors that,
That come into play.
human error, for one,
People misjudging the speed of, say,
an oncoming train,
ignoring warning signals.
or simply not paying attention.
So what's the solution?
How do we make these crossings safer?
Especially given that they're not going away anytime soon.
Well, ideally,
Crossings should be eliminated altogether.
especially in areas with,
Heavy traffic, high-speed lines,
or where the crossing is.
rarely used.
But that's not always feasible.
Of course, there are going to be situations where you can't just...
Reroute an entire railway line.
or build a massive overpass.
So for those crossings that are here to stay,
How do you make them as safe as possible?
it seems like it's not just about technology.
But also about,
Human behavior?
you've hit the nail on the head.
It's about that,
A crucial interaction between human actions and technological safeguards.
So it's not just about relying on people to,
Follow the rules.
but also about designing systems that...
Minimize the risk of human error in the first place.
Exactly.
It's amazing, really. Ingenuity goes into keeping something
As massive and powerful as a train,
safely,
chugging along the tracks.
It's a testament to human innovation, that's for sure.
And the fascinating thing is,
We've only,
scratch the surface today.
all right.
We've journeyed from the physics of braking distances,
That stretch for,
what seems like miles,
to those invisible track circuits.
like silent guardians,
Watching over every inch of the rails.
We've uncovered the secrets of relays,
Those unsung heroes of,
reliability,
and explored the high-tech world of Control Center.
where it feels like,
The future of rail is already,
unfolded.
and let's not forget the,
The ambitious quest for, with
interoperability.
ERTMS paving the way for
More unified and efficient European railway network.
it's an exciting time to,
Witness these technological advancements.
it really is,
It's like we're moving toward a future.
where trains can practically,
Think for themselves.
communicating with each other,
And adapting to their environment in ways we could only have.
dreamed of a few decades ago.
But
Thinking about these futuristic level 3 ERTMS
their
systems,
trains are practically
reporting their every move in real time.
It begs the question.
Could we ever see a truly global rail network?
I mean,
Imagine boarding a train in, say,
I mean,
and stepping off in,
go with you.
without ever having to,
Change trains.
That would be
I
incredible.
mean, it'd be a journey for the ages, wouldn't it?
The romance of the rail is taken to a whole new level. But the question is,
Do we ever get there?
will we ever overcome,
The technological and geopolitical hurdles.
to make that kind of seamless global connectivity,
Reality, or will
those regional differences,
in the ever-evolving landscape of technology?
always be factors?
That's the billion-dollar question, isn't it?
And it's one that will likely be,
Debated and pondered for years to come.
but I think one thing is certain.
The pursuit of that dream.
The quest for
Seamless global connectivity.
will undoubtedly continue to.
Will drive incredible innovation in the world of rail.
Absolutely.
And who knows?
What incredible technologies and solutions will,
Uncover along the way.
well, on that note,
It seems we've reached,
the end of the line.
for today's deep dive,
But just like those tracks,
stretching out towards the horizon.
the future of rail is, well,
Full of possibilities. It's been a fascinating journey.
exploring the,
The intricate world of railway safety and interoperability.
and I have a feeling,
This isn't the last time we'll be talking about.
the magic that happens when those steel wheels meet the rails.
Until next time.
Safe travels, everyone.